Hey, you guys ready? This shouldn't take long, so. Yeah, okay, let's start. Okay, we're at the point in physics now. I've said this for the last couple of days. If you get physics, I can pretty much throw any formula at you and explain it to you really carefully, or really quickly even. Some of you I've even noticed have been using this formula on kinetic energy already without me even explaining it, because if you understand physics...
Marty Duncan, dial 103, Marty?
If you understand how physics works, it's really just another formula and rearranging stuff. That makes sense? One of the downsides, though, is that if you're still struggling with physics, the more we do, it doesn't really get better. But hopefully you're improving. If you're struggling, you need to have good math skills, right? If you're good at math, you're probably going to be good at physics. If you struggle with math, physics is probably not your place. So today is going to be a very typical physics lesson. It doesn't take overly long. I'm going to explain a concept. I'm going to show you a formula, and we'll do like 3 examples. Any questions? Okay. Before we start, I just want to recap 2 things we talked about yesterday. Yesterday we talked about how gravity works. Gravity is quite important because of potential energy. Here are 2 different objects. Actually, they're pretty similar in weight. This eraser is very light. Here's 2 objects. They're very different in weight. This one's reasonably heavy. This is very, very light. If I let them go, how is gravity going to affect them? The exact same. They should hit the ground at the exact same time. That being said, if I were to drop a bowling ball on you, or I were to drop that eraser bit on you, which one hurts more?
Bowling ball, erasers.
Bowling ball.
I
know, you're just being silly though. The reason why is that it's not the gravity that hurts. It's the force that gravity applies that's really the problem. So we learned a formula yesterday called F little g equals mg. The force of gravity depends on the mass times gravity. And we learned one more formula that was mass times gravity times height is how much potential energy there is due to gravity. The point of the story being that although everything falls at the same rate, the amount of energy and the amount of force is dependent on mass. Today's topic is something called kinetic energy. When I was holding the eraser up here, is it actually doing anything yet? So no, at this point here it has only potential energy. But that potential energy is going to get converted into a different form of energy, kinetic energy, the energy of like moving, motion. Okay? And so the amount of kinetic energy depends on how fast it's moving and how heavy the object is. Let me give you some examples here. Anybody ever been shot with like a paintball gun?
Yeah.
Okay. Well, a paintball gun shoots a bullet fairly quickly, but the paintball itself is fairly small and light and it explodes on impact. That's very different than if you got shot with a bullet, because a bullet is hard, compact, and quite heavy in comparison. Does that make sense? Well, the bullet has more kinetic energy. But you know what has even more kinetic energy than a bullet would be a cannonball. Because it's traveling really fast, but now the cannonball is really big. Does that make sense? So like there's a couple different ways to get kinetic energy. You could throw something really fast, or it could be really heavy. Imagine that a big car, like a truck, was all of a sudden rolling down the hill very slowly, but it was such a big truck that you couldn't actually stop it. Like you wouldn't want to get in front and try to push on it like you would with like a smaller vehicle. It has a lot of energy because of the fact that it's so big, but it's not really moving all that fast. Whereas if I throw a baseball is very small, but I'm throwing it so fast that it also has a lot of energy. Does that make sense? So, here's the formula. Again, if you know how to use a formula, it's really straightforward. To find energy with a little k in the corner, k just means it's kinetic energy, you need to take 1/2 of whatever the mass is and square the velocity. That's it. So let's try some examples. So you've got a car. The car is 1,500 kilograms and it's moving 14 meters per second. How much energy does it have? Well, like I said, if you understand how to use a formula, it's fairly straightforward. The formula for kinetic energy is 1/2 mass velocity squared.
It's a nice car.
That's a nice car. Nice Hyundai. Alright, well the mass was 1,500 kilograms. And the velocity was 14 meters per second. We've actually encountered squaring a number before. I might recommend, if you'd like to, you can actually write the 14 next to it itself. Or if you want to, you can just use the little squared button on your calculator. I'm going to write it next to itself, but you don't have to do that. So, take your calculator. 1/2 times 1,500 times 14 times 14.
Why do you do it times 14?
Because it's v squared.
Okay.
Does that make sense? The squared symbol means you have two of them. So here's what my calculator says to me. It doesn't say it, but that's what I read, I guess. It'd be cool if your calculator said it to you. It'd be cool. I feel like having like your own like Tony Stark like robot thing inside your head where you can talk to Jarvis. And, Jarvis, what's the kinetic energy? And he just tells it to you. No. Alright, we're not done though. I got 3 problems I gotta fix here. The first problem is I wrote down a number without a unit, and your science teacher, for better or for worse, you have a picky teacher who wants to train you to do things well. And so if you ever write down a number without a unit next to it, you're gonna lose some marks. So I'm sorry, I want to train you to do things properly. So we need a unit here. The unit you could write down as kilograms, and then there's actually 2 sets of meters and 2 sets of seconds. You could call it a kilogram meter squared second squared. That being said, we have a better unit to use instead of that. Good, yeah, we can call it a joule. So you could call it a joule instead. That's probably a better choice, actually. So that's counted for one of the problems. We have another problem, though. We don't have the right number of digits. Based on the digits we're allowed to have, 14 has 2 digits. 14 still has 2 digits. 1,500 has 4 digits. By the way, the number 1/2 is not really relevant because it's not a measured value. So don't think that like the number 1 has 1 digit. That's not how it works. So we get 2 digits. So one of the problems then is that this has 6 digits. So what you could do is say, well, I'm going to keep the 1, and then the 4 makes it a 5. But I can't just call it 15 because those aren't the same thing, right? So a couple of ways you could fix it is you could times by 10 to the power of something. Well, based on this, you'd have to go over 1, 2, 3, 4 times, I guess. So times 10 to the 4 joules. That's one option. There is another option, actually. If you didn't want to write it like this, you could convert it using one of the like kilo, centi, milli type prefixes. If you wanted to, you could maybe make it 15 times 10 to the... No, let's not do that. What is the times 10 to the 6 one? Is that a mega? Mega is times 10 to the 6?
Mega.
Okay, so maybe what I might do is I might move this over 4, 5, 6 times, make it 0.15, and call it a megajoule. You could do that if you wanted. So I really made it 0.15 times 10 to the 6 joules. And then a 10 to the 6 is a mega. Either of those would be valid. Whichever one you like better. Does that make sense? So either this or this. One last thought. Do we need a direction? No, I mentioned it yesterday at the end of class. Energy has been defined as a scalar, in part because energy sometimes goes all directions. Now, this particular car is probably traveling forward, okay? But there are other forms of energy, for example, light energy. These lights are giving off energy. Which way is the energy going? It's going all directions, right? It's going down, up, sideways, northwest, east, south. So by definition, we've just decided to call energy a scalar without a direction. So even though there might feel like you could put a direction behind it, we don't. Okay. Any questions? Easy peasy? Fairly? All right, let's try another one. Here's a baseball. The baseball has a mass of 1.45 grams, and it's been thrown with a certain velocity. We want to find its energy. we're using that same formula. So energy kinetic is equal to 1/2 of whatever your mass times your velocity is. But I have thrown a curveball into this baseball question. Get that pun? There's a curveball here. What's the curve?
What?
Well, what's the twist?
You got a ground.
Good. You guys see that? I've thrown it into grams.
Strike 3, yeah.
Strike 3. Baseball metaphor is working well. So 145 grams has to be converted into kilograms. A kilogram means you need to make something with a times 10 to the 3. So to make this times 10 to the 3, you'd have to make it 0.145 times 10 to the 3 grams. So basically you're dividing by 1,000. 0.145 kilograms is the number we need to use. Does that make sense? Well, let's plug the numbers in. 1/2, 0.145 kilograms. And then I'm just going to write it 26 meters per second. I'm just going to write the squared afterwards. You guys know where to find the squared button on your calculator?
Yeah.
Okay, so maybe I'll just do that from now on. 1/2 times 0.145 times 26 squared.
How do you know how to get 0.145?
In order to get from grams to kilograms, you're dividing by 1,000. So here's what I got, 4901. Didn't do it right. Anybody else get 4901? Okay, so it is just you, Josh, sorry. Call me over if you still don't get it, okay? Okay, details time. We need the right number of sig digs, that's 2. And we need the right unit, joules. And we do not need a direction because it's an energy. We're done. Did you get it to work? Okay, good. Do you guys get what I say when I'm telling you that, like, at a certain point, physics is very similar? Like, if you know how to use a formula, it's very, very similar. You know, it's just more math. All right, last example. Steven Stamkos, future Vancouver Canuck, I hope, is
No.
no, not gonna happen. I heard that he might get traded to Calgary. Right. Steven Stamkos is flexing his stick like crazy here. He can shoot a puck apparently with 73 joules of energy. I just made a number up. I don't know whether that's right or not, but hypothetically, that's how much energy he can shoot a hockey puck. I'm also going to give you the mass. The twist here now is we need to try to find a way to solve for the speed. So it's the same formula. Energy kinetic equals 1/2 mv squared. But we're not solving for EK. So I'm going to plug in numbers where I can. Right here, I'm going to plug in 73 joules. But can I change it? Rather than writing joules, can I write the other units?
kg.
Kilogram? Meters squared over seconds squared. You can also use Newton meters, but that doesn't really apply in this scenario. We knew the mass, right? Yeah, 0.21. So now it's a math problem. How do you get a V by itself? What was that? Okay, so maybe let's just do a bit of an aside here. Let's just do a quick math tutorial. Let's say that these numbers here, let's just say they were just numbers. So let's say it was 3 equals 1/2 times 7x squared. Let's say that that was what you were given as like a math question. You guys ever learned how to solve this before?
Yeah.
How are the 1/2 and the 7 and the x related? They're all being multiplied together. So to get rid of things that are being multiplied by each other, you have to divide. So what you might need to do is divide by 1/2 and divide by 7. That would make all of this go away. Here's the part I really want to focus on. When you have x squared, how do you not make it squared anymore? Good, you square root. Yeah, you square root both sides. So with that little mini math lesson there, let's try doing the exact same thing above here. So let me get rid of all this. There is a 1/2 right here. We do not want that 1/2 here, so I'm going to divide by 1/2 on both sides. And while I'm at it, I'm also going to divide by 0.21 kilograms, because I really don't want 0.21 kilograms anymore. That makes sense? So all of this right here, bye-bye. While I'm over on this side over here, one of my units should cancel. See how there's a kilograms right here and a kilograms right here? So in your calculators, you gotta be really careful with this part, by the way. I'm just gonna show a calculator on the screen here. You should take 73, you should divide by 1/2. Let's do it like this. 73 divided by bracket 1/2. And then also divide it by 0.21. So they get that number. Anybody able to get that number in their calculator? So I did 73, I divided by 1/2. And then I divided by 0.21 as well. Here's another way you could do it if your calculator operates like this. You can go 73 divided by bracket 0.5, because that's 1/2. And then you could times by 0.21. But since it's in like this bracket underneath the divided by sign, they're both being divided. Either way, you need to get this number here. Okay. Now, when you write this number down on paper, I don't need you to write all of the digits, but I do need you to keep in mind that we should use this whole number before I square root it. So I like to write it down like this myself. I might write down 695, and I write a ... afterwards. And I do this for myself to remind myself that I don't actually want to square root 695, but that there's more digits that I need to keep track of later. So that's equal to v squared. So then to get v by itself, you got to square root both sides. So don't do this. Don't take 695 and square root it, however your calculator does that. Because you're not square rooting 695, you actually want to square root 695.2380952. Most calculators have a button on it that allows you to bring up the previous answer. Does everyone know where to find that on their calculator? Have you seen that before? Okay, I'll come around with you and work with you guys individually. If you have one of these calculators, you do this. You go the square root, and then underneath the minus sign on one of these calculators, there's ANS. If you can do second there and make answer come up, what it'll do is it'll take your last number, the whole number, not just the rounded number, it'll take the whole number and square root it to get this number. Somewhere on your calculator there might be an ANS for answer, something similar. I'll come troubleshoot later though. Because what I don't want you to do is this. Don't square root 695. Because do you see how the answers are slightly different? One was 2636.73. The other one was 2636.28. It may make just a little bit of difference. So make sure you actually use the whole value of the 695. Oh wait, last step. How many sig digs do I get? 2 it looks like. So 26. For units, you see how this one right here was meters squared? But you square rooted it. So now it's just meters. And this unit right here used to be seconds squared, but you square rooted it, so it's just seconds. There's your speed. You can shoot a puck at 26 meters per second.
I need help after this.
This one's probably one of the more challenging ones. Like the first 2 questions we did are a little more straightforward. This one's more challenging because you have to take the 1/2 and the mass. You have to divide them both to the other side, and then you have to square root. Any questions? Okay, that's it. Actually, that's all I got. So.